Okay, today in regular chemistry, we are going to start Chapter 4, Atomic Structure, and today we want to talk about early models and then the current model that we currently use, and then we'll also talk about some of the scientists that are given credit with discovering certain subatomic particles. So Democritus, who lived 470 to 370 BC, thought that matter could be divided into smaller and smaller particles until it could not be divided anymore, and he called these particles atoms, which means indivisible. Aristotle, who lived close to Democritus' time, did not believe in atoms, but he thought all matter was continuous. So he didn't think it was made of anything smaller. And believe it or not, people believed Aristotle's views until the 8th century, and did not accept Democritus. In the 1800s, there was an English school teacher by the name of John Dalton. And so John Dalton did some research and did some work on his own, and he came up with the following hypothesis, most of which is accepted today still. He said, first of all, that all matter is composed of very small particles called atoms. So he kind of agreed with Democritus there. He said that atoms cannot be broken down into smaller substances, nor can atoms be created or destroyed. He said that all atoms of an element are exactly alike, or they're identical, and that atoms of different elements are quite unalike, or they're different from the atom you're talking about. And he said atoms can combine in small, simple ratios to form compounds. And then he said chemical reactions occur when atoms are separated, joined, or rearranged. And then atoms of an element never change into atoms of another element during chemical reactions. Now, he didn't say nuclear reactions, he said chemical. Well, we know currently that a couple of these have been modified. When he said atoms cannot be broken down into smaller substances, he did not realize that atoms are made up of things like protons and neutrons and electrons, and then even other ones like neutrinos and stuff. Okay, so that one's been kind of modified. And we also know that atoms of an element are not exactly alike because they can differ in their number of neutrons, and so they have different masses, and so we call those isotopes. And so we know that one has been modified. But for the most part, John Dalton's hypothesis is what we currently believe. John Dalton's hypothesis led to work of people trying to discover about the things that made up an atom. And so J.J. Thomson in 1897 discovered the electron using the cathode ray tube. He didn't determine its charge or its mass, he just discovered it. And if you'll make note of page 107 and 110 shows some of his work in the cathode ray tube. So when you're in your ebook, make sure that you read that. Okay. Millikan was a gentleman that determined the first accurate measurement of the electron's charge. And determined the mass to be about 1,800 times smaller than a hydrogen atom. And it shows Millikan's oil drop experiment on page 109. So make sure you check that out. And then Goldstein, in about 1886, determined that a proton has a positive charge and a mass about 1,800 times greater than the electron. And then Chadwick in 1932 discovered the neutron, determined it has no charge and the same mass as a proton. Now, Rutherford made a prediction that the neutron existed, but he didn't know anything about it. So we give the credit to Chadwick. So those were the early models. So current models, we have the nuclear atom. Part of the nuclear atom, what we have learned about it comes from Rutherford and his famous gold foil experiment, which is shown on page 112 of your textbook. And what he did is he shot small positive particles, which were alpha particles, at a thin sheet of foil, a thin sheet of gold foil. Most of them would pass through, but a few were deflected at large angles and some bouncing back. From this, he got the idea that the atom has a very small core and a lot of empty space. The core, called the nucleus, contained positive charges in almost all of the mass of the atom. And then Niels Bohr determined that electrons in atoms exist in specific regions at various distances from the nucleus, rotating in orbits like planets around the sun. So we sometimes call his model the planetary model. And he said if electrons absorbed enough energy, they could become excited and move from their ground state to a higher energy level. So in other words, he said that if you have the nucleus, you know that in the nucleus you have protons and neutrons, and then he said outside the nucleus you have these energy levels, and that is where you found electrons revolving, and they would stay in these paths. It wouldn't deviate from them. And he would say, circles are not very good. So he said they just stayed in that path. And then if you could get this electron in its ground state, if it could absorb enough energy, you could get it to move from this energy level to this one, or from this energy level into this one, okay? The quantum mechanics theory is the one that we currently is the one we use, and it's a mathematical model. It was proposed by Schrodinger in 1926. And the main difference between his theory and Bohr's is that they said electrons are not visualized as revolving around the nucleus in orbits, but as occupying orbitals, which are cloud-like regions around the nucleus. So in other words, instead of the electron being like in that just little path right there, it could deviate and it would make a cloud around the nucleus, and it would be a 3D cloud. So that is it for your first part of notes, and that will let you do problems 1 through 4 on your study guide. Thank you.